Hey guys, we're here for our next session. This one will be a technical workshop around generalizing flash loans. Kendrick, do you think you can give a quick background on yourself before you jump in?
Sure. Well, my name is Kendrick. I work for OmiseGO as an SRE, and I'm currently based in Brisbane, Australia. This talk will be titled "Generalizing Flash Loans," and it'll be mainly about kind of my journey into playing around with flash loans. I'm just going to toggle the video off now. So, can everyone hear me? Everything? Can everyone hear me on the chat? Crowdcast coming soon.
Oh, that's strange. Is that true for everyone else? Because I can see his window. Okay. Bill, just refresh your browser and it should work.
Okay. So, well, thanks everyone for tuning in. This is Generalizing Flash Loans, and I'll be mainly talking about my journey into modularizing Flash loan logic. There's some social links at the top of each page. It's my GitHub, my Twitter, my Instagram, and the links to the slides and some code examples if you're interested. So just before I start, I want to clarify what I mean by modularizing logic. And by that, I mean that I'm actually separating protocol handling logic. So for example, Uniswap-specific logic, compound-specific logic, and maker-specific contract into different contracts after you get your flash loan assets. Now, if you haven't done a flash loan before, don't worry. I'll be going through some of the basics of a flash loan in this presentation. This is a very, very important slide, so please pay attention. My cat has an Instagram at mr.miso.oz. Please follow him. I'll be very, very grateful for everyone who does. About me again, I'm a SRE at OmiseGO, and I've previously worked for the Ethereum Foundation on the Applied Zero Knowledge team, and I'm currently based in Brisbane, Australia. So this would kind of be the agenda for the talk today. I would go through sort of like the motivation and goals of this talk, something called proxies, a bit about flash loans, and then how can we generalize the flash loans, some future work, and some Q&A session. So the motivation for this talk actually arose when me and my buddy were building out Dash.exchange, which is this site that actually combines multiple protocols to allow you to hedge against assets. The inspiration came from Black Thursday when we were all highly leveraged on ETH. And in the course of one day, we lost over 50% of our collateral. And we wanted a way to be able to say, hey, we want to be able to instantly swap from our collateral from Ether to DAI. So if Ether, the volatile asset, drops in value, our collateral remains the same. But we also want to take that a step further and be able to swap our DEP from, say, DAI to Ether in one transaction. And so that way, our DEP kind of falls along with the price. As the price of Ether tanks, our DEP tanks as well. So in a way, in an event like Black Thursday, we actually gain money. This is quite a number of technical difficulties. Well, first of all, you need to integrate. You don't want to have any upfront liquidity, so you need to utilize flash loans. And not only that, you need to integrate it so it works seamlessly with multiple DeFi protocols such as Uniswap and Compound, and it needs to work within one transaction. And upon building this, we realized that there isn't a lot of content out there for flash loans. And so I decided to kind of create a presentation for it, documenting my experience. And so the goal of this talk is to basically share what I learned about building on top of flash loans, like what are the best practices. I have to emphasize that this is a very opinionated way of opinionated practice of building on top of flash loans. So before we start, I would like to talk a little bit about proxies, and specifically this utility library called dsproxy, which is made by the Maker team. All you need to know is that it allows you to load logic. This proxy allows you to load logic from another contract within its own context. It basically allows you to perform multiple atomic transactions in one call. And the reason why I personally like dsproxy over, say, OpenZeppelin's implementation or Gnosis is because dsproxy's testing suite is written in Nix, which is an esoteric functional programming language, which I really enjoy. And there's also a lot of third-party supports, for example, ds-off, ds-log, ds-guard, and so on, which you can just plug in or take out as needed. It's very bare bones. It's very composable. So all you need to know is, say, hypothetically, there's a situation where there's you, the user, and a contract A, which contains functions to call contracts B, C, and D. In order to utilize it, and the calls to contracts B, C, and D happen separately. So if you would like to call contract B, contract C, and contract D, you would need to have a total of 3 calls separately. However, with the dsproxy, you can execute it all in one transaction. So what happens is that you can first tell dsproxy to execute the functions from contract A. dsproxy loads the context from contract A into itself. It then calls contracts B, C, and D in one transaction. So I have to emphasize that the proxy is able to load the context from contract A and execute these sequence of actions atomically. And it's all done under the context of dsproxy. So that's pretty much all you need to know about what a proxy does. So a really, really good use case is, say, if I want to swap compound debt from asset A to asset B, which requires 5 separate transactions. I would first need to take out a flash loan of asset A. I would then need to repay the debt to A on compound, take out a loan from B on compound, convert asset A to asset B, sorry, there's a typo, and then return flash loan of asset A to the flash loaner. So normally you can't even do this because you are required to perform, or if you were to take out a flash loan, you need to do all of these transactions within one call. However, with the proxy, you're able to kind of batch these kinds of logic into one call, which is all you need to know about why we need to use a proxy in this case. It enables you to do the logic batching. Now I would like to cover a little bit about the flash loan basics. So for those who are unfamiliar with flash loans allows you to kind of borrow some asset without collateral. In a way, it's like an under-collateralized loan, but the caveat is that you need to return the borrowed assets and some fees within the same transaction. So a common use case for flash loans would be, well, arbitrage. I want to be able to arbitrage between 2 exchanges without any upfront liquidity. I can use flash loans to kind of facilitate that trade. And my main issue with flash loans right now is that it's a developer feature. It's not very user friendly, and it's also quite technical. If you haven't done any Solidity before or any smart contract development, as you need to deploy a smart contract containing a callback logic to handle what to do with the flash loans. I'll touch on the callback logic a little bit more in the presentation, so don't worry about that. So this is kind of a typical setup that contains a flash loan. There's actually 2 contracts. There's contract A, which you deployed with the flash loan callback logic, and contract B, which is the flash loan provider. So for example, Aave, DYDX, or Uniswap V2. So to kind of give you guys like an understanding of the flow, if you would like to perform a flash loan, you would first need to initiate the flash loan to contract A. Contract A would then request the flash loan from contract B. Contract B sends the flash loans funds to contract A via the callback function. Again, we'll kind of touch upon this callback function a bit later on. Now, since contract A now has the funds, it can perform some kind of logic. So like arbitraging, or I want to swap my debt, or I want to swap my collateral. And once it's done, it sends back the original funds and the fees back to contract B. Optionally, contract A can also send back any additional profits gained back to the column. And now contract B, which is the liquidity, the flash loan provider, will check if its reserves matches some criteria. So for example, the user actually refunded me the amount plus the fees. If that doesn't happen, then it's going to revert and this entire transaction is canceled. And here's a kind of like a skeleton on how you would perform a flash loan on Aave. In this case, the execute operation is the hard-coded callback function that you need to have in your contract in order for it to be quote-unquote flash loan compatible. The execute operation also needs to have 4 parameters: an address, a uint, and a byte, and some bytes in order for it to be valid. Regarding the flow from before, if we would like to initiate the flash loan, we would call function init flash loan if, of which it will call Aave lending pool dot flash loan. And within Aave lending pool dot flash loan, it will then call the callback function execute operation. And that's how like the flow kind of goes. You call the function, you call the lending, you ask the lending pool to give you a flash loan, and the lending pool would then call your callback function. In this case, it would be execute operation. Now this is Aave specific, which is different from Uniswap. So Uniswap actually has a hard-coded callback function called Uniswap v2 call, which accepts some address, a uint, and some bytes. And so the setup is exactly the same as Aave. However, the callback function is now called Uniswap v2 call. You would call init flash loan if, of which it will call Uniswap exchange.swap. And within Uniswap exchange.swap, it will then call Uniswap v2 call. Now let's check out dydx. dydx has a bit of a dydx's callback function is a bit different. It accepts a address, a custom tuple type called account.info, and some bytes. And now the hard-coded callback function is called call function. So when you call init flash loan if, the dydx solo margin would execute the call function if you would like to perform a flash loan. Me and my buddy, we made a website with a lot more code examples, a lot more details on how you can kind of play around with these flash loans. So if you're interested, please do check out money-lagos.studydefi.com. It's an open source library. So if you'd like to contribute, or if you have any issues, if you want to make a PR, feel free to do so. Now going back to the issue at hand. So what's the problem with all these flash loan setups? Well, the biggest issue is that all the callback functions are different. All the hard-coded callback functions are different. If you want a contract to be Aave flash loan compatible, you need an execute operation callback function. If you want it to be dydx compatible, you need a function called call function. If you want it to be Uniswap v2 compatible, it needs to have Uniswap v2 call. And not only that, the callback function parameters are also different. So for Aave, you get an address, uint, and some bytes. For dydx, you get an address, a custom tuple called account.info, and some bytes. And for Uniswap v2, you get address, uint, and some bytes. And also, I'm pretty sure that the uint amount 0 and uint amount 1 in Uniswap is different from the uint amount and the unit fee in Aave. So even though the types are the same, the amount, the actual content of the arguments might be slightly different. So the problem is you need to your contract that is flash loan compatible also needs to provide specific protocol logic and possibly their respective libraries for each flash loan. This makes it very hard to compose different protocol logic together unless they're in the same contract. So for example, if I want to perform a flash loan that liquidates some file on, if I want to get some funds from the flash loan to then use it to liquidate some file on Maker, convert the earnings into wrapped ETH on Uniswap, and then do some kind of borrow/supply operation compound, I need to have the protocol logic and libraries of Maker, of Uniswap, and of Compound on the same contract, on the same flash loan contract. So that's just 3 protocols. Like we've been seeing the explosion of DeFi protocols recently. What if I want to integrate 5, 6, 7, 8, 9 different DeFi protocols? If you can't modularize the logic, and if you can't separate out these libraries and these interfaces from the actual flash loan contract, you're very, very likely to exceed the max contract size. So wouldn't it be great if we could integrate with as many DeFi protocols as we want with flash loans? Well, yes, we can. We just need to generalize them. So introducing generalizing flash loans. So if we take the problem and kind of abstract it out even further, the main problem we're trying to solve is how can we separate out the logic from the hard-coded callback function? So, well, the answer is we can just use a proxy and some really smart contract abstractions. So recall the execution flow of a flash loan. You have one contract which is flash loan compatible that contains the hard-coded callback logic, and contract B, which is the liquidity provider. So we know that we can't change contract B, and we know we can't change the message sender. So the only thing we can change is contract A with the flash loan callback logic. And we can actually kind of generalize it into 3 different sections, which is a proxy, a callback function, and the callback logic. So the reason why we're able to generalize it to a proxy and callback logic is, if you recall, on the proxy situation, we can use proxies to execute logic from another contract. Woo! So this is the new setup flow now. It looks a little bit more complicated, but I'll go through it with you guys to make sure that we all get the flow. So now, instead of having a flash loan compatible contract, you now have a proxy contract, a contract which contains the logic on what to do with the flash loan funds, and a contract which is simply the callback wrapper, which is the contract which contains the hard-coded callback wrapper. So, for example, if you would like to initiate a quote-unquote generalized flash loans, you would first initiate flash loans with some encoded parameters. These encoded parameters will be ABI encoded parameters. I won't go into too much detail on this, but you just need to know that's ABI encoded. So the user initiates the flash loans with these encoded parameters to contract A. Contract A will then request the flash loans from contract D, while specifying contract C as the callback callee. Now, this is important because contract A is a generic proxy, so you can use your existing proxies like Gnosis's proxy, or you can use MakerDAO's proxy, or OpenZeppelin's proxy. You do not need to extend on any existing proxy. You can simply say, hey, call contract C, which contains the callback wrapper. So contract A requests the flash loans from contract D and specifies contract C as the callback callee. Now this function call gets called to contract D. Contract D will then call contract C's relevant callback function. For example, execute operation or call function or Uniswap v2 call, while supplying the loans to contract C. Here, contract C now has the funds. It then transfers the loan to contract A and calls the encoded function, both of which the address of contract A and the encoded functions are injected from the ABI encoded parameters. Yes, from the ABI encoded parameters. And now contract, sorry. Oh, yes. So now contract A has the loans. It also has the encoded functions which is obtained, and now it's able to load contract B's logic function into its own context. And how it knows where contract B is situated is from step 1, where we sent it the ABI encoded parameters. So now contract A has the logic. It also has the funds. And so contract A basically executes the logic. So for example, arbitrage along with the funds and sends back the funds and the fees to contract D. Optionally, it can send back some profits to the user, but yeah, optionally. So a lot of people might ask, what's the point of this? It sounds like a lot of unnecessary complexity. I don't need to abstract this out so much. Well, the answer is now you can execute a series of operations atomically execute a series of operations in conjunction with flash loans. I really like this because now that you can execute a series of operations atomically, it essentially means that you're able to make flash loans more user-friendly, and you're able to allow non-developers to participate. And I'm a big fan of lowering the entry to barrier. So I think another app called Furocombo actually has integrated flash loans into their money Lego dApp, which allows you to batch transactions into it. And I really, really like these sorts of tools, which kind of enables more people to participate in the ecosystem. Generalizing these flash loans also has a lot of nice side effects, such as it makes your contract size a lot smaller, your logic a lot more manageable, because now, hey, I know that, hey, Uniswap logic is in the Uniswap logic module, my Maker logic is in the Maker module, and my compound logic is in the compound module, and so on. So if I want to do a flash loan in conjunctions with these logic, I can do it. It's very, very easy. That was actually it. That was how you generalize flash loans, and a little bit some future work that I would like to talk about is that I would like to see possibly a recipe marketplace for flash loan logic on top of Furocombo or something, where users can publish, hey, if you use this module, you can do XYZ operations on XYZ protocol, but I charge a 0.1% fee for your convenience. And I would really like to see these sorts of recipe marketplace happen. Yeah, that's pretty much it. If you guys would like to check out if you guys would like to play around with a sandbox mainnet environment, feel free to shoot me an email, ping me on Telegram or Twitter. I could send you a link or ping me on Discord. I can definitely guide you guys through it. That's my GitHub, that's my Twitter, my Instagram, and the URL for the slide presentations and the code examples for generalizing flash loans. So tinyurl.com/fl-2020 contains the links to the slides and the code examples. Yeah, any questions? So I think Lecky asked, would this cause way more gas? The short answer is yes. It would cause a lot more gas because you're kind of chaining a lot more calls. Sorry, it wouldn't be a lot more gas. It would be slightly more gas as you'd be chaining multiple operations into one transaction. Again, it depends on the logic you want to facilitate. If you're doing logic which is very gas heavy, for example, opening up, liquidating someone, or swapping out depth on compound, not swapping out collateral compound, yes, this would cause way more gas, but simply abstracting it and generalizing it shouldn't increase it by too much. That's with my experience, my limited experience, I have to say.
All right, Kendrick, maybe you can pick one last question. We need to transition to the next session.
Yeah. So I don't think anyone has any more questions. That's the thing.
There's some in the chat, I think.
Some in the chat.
Oh, never mind. I'm blind, apparently.
Oh, there's one more. Could you tell us a bit more about Furu Combo from James Poss? Oh, it's actually not my app. My app is just something that I really like. It's more like you can execute multiple transactions in one call. So if you want to take your ETH, convert it to DAI, convert it to 0x, or convert it to Maker on Uniswap, you can do it via Furu Combo. But I think that's about it. And wait, how do you create a proxy with Maker's language jargon from Frank Kruz? Oh, the answer is there is a GitHub called Much Clearer Die, which I really enjoy. I'm going to paste it on the chat right now. Much Clearer Die. If you want to understand Maker's language jargon, check out Much Clearer Die. Yes.
All right, thank you so much for this really great talk. We're going to move on to the next session. Thanks.